Hello everyone, welcome all of you to our channel Amar Concept House. Students, in my first video of Thermodynamics Part 1, we have already discussed about what is system, what is surrounding and the types of the system. There are three types of systems are there. One is open system, closed system and isolated system. What is the open system? The open system is a system in which both mass and energy get transferred to the surrounding. And what is closed system? A closed system is a system in which there is no mass transfer, only energy get transferred to the surrounding. Actually, I forgot to tell one thing in my past video, that in thermodynamics, the energy transfer can be possible in two ways. The energy get transferred to the surrounding in two ways, either in terms of heat or in terms of work. Suppose I will take an example. मान लो यहाँ पे मेरे पास कोई गैस है, ओके और यहाँ पे मैं एक पिस्टन लगा दूँ. सपोज आई विल अटैच ए पिस्टन ओवर हियर और दिस इज ए इंसुलेटिंग बाउंड्री. इंसुलेटिंग बाउंड्री मीन्स heat cannot be transferred to the surrounding. Okay, now please tell me if the system is open or closed. Is it a open system? It is not a open system because there is a piston over here, so mass cannot be transferred to the surrounding, and it is a insulating boundary, so there is neither mass transfer nor energy transfer possible. Is it a closed system? In closed system there is no mass transfer, only energy get transferred to the surrounding. So how is it a closed system? It is an insulating boundary. Heat cannot be transferred to the surrounding. Yes, it is a closed system. How is it a closed system? How is it a closed system? So when we heat it, when we heat the container, it may expand. The gas may expand. So piston try to move off. As piston move off, so piston will do some work. So it releases some energy. Okay. So here heat cannot be transferred to the surrounding, but work transferred to the surrounding. So the energy can be transferred to the surrounding. So it is a closed system. Let us come to our today's topic. Now in this video, let's talk about what is macroscopic and microscopic approaches in thermodynamics. Okay, this is not a very difficult topic to understand. Okay, we all know that each substance, suppose we take this is a substance. Suppose you look at it in the microscope, what we observe? It is made of very large number of molecules. It is made up of a large number of molecules. So these are the molecules which make up this particular substance. Clear? If I have to study about all the properties of this particular substance, then we must know about these two approaches, what is macroscopic and microscopic approaches in thermodynamics. Now let us know about the macroscopic approaches in thermodynamics. What is macroscopic approach in thermodynamics? Okay. Now to understand about the property of this particular substance, I would have to take a collection of these molecules as one. I would have to take a collection of these molecules as one or a single one entity. So I would have to combine all these molecules into a single molecule or single entity. Then I will study that whatever changes are occurring in this particular component, we would assume that the same changes that be occurring to take place of this entire substance. Clear? So when we consider a Volcom modulus for finding the properties of entire substance, then it comes under the macroscopic property or macroscopic approaches in thermodynamics. Okay, it's sometimes called as classical thermodynamics. Now come to the microscopic approaches in thermodynamics. What is microscopic approaches in thermodynamics? Again the assumption is same, that any substance is made up of a very large number of small infinite molecules. Okay, let's draw the diagram once again. This is our substance and it made up of this a very small and large number of infinite number of particles. Now each particle or each molecule of this substance will have a different kind of velocity, will have different kind of motion also. Also it has different positions. So in microscopic point of view, we need to consider each and every molecule as a separate entity or single entity, which means this molecule won't have its different properties. Okay, that means every molecules have its own set of equations. Hope you understand the basic difference between the macroscopic and microscopic approaches in thermodynamics. That means in macroscopic point of view, we consider a collection of molecules as a single entity, whereas in microscopic point of view, we consider each and every molecule as a separate or single entity. Okay. Now in this, we consider each and every molecule as a single or independent entity. That means this will have to be studied for its velocity, this will have to be studied for its energy, this will have to be studied for its position, this will have to be studied for its momentum. Okay, so infinite number of equations can be solved for this particular substance in microscopic approach or microscopic point of view. Now it is very difficult for us to analyze or express this. So what we do? We calculate all the equations. Then we basically qualify the properties by taking an average value. Now I want to give some notes. What is macroscopic approach? In macroscopic approaches in thermodynamics, the behavior of individual molecules is not taken into consideration, but the average behavior of molecule is taken into consideration. In macroscopic approach, the behavior of individual molecules is not taken into consideration, but the average behavior of molecule is taken into consideration. This approach also known as classical approach of thermodynamics. Now what is the definition of microscopic approaches in thermodynamics? Microscopic approach in thermodynamics. In microscopic approach in thermodynamics, the behavior of individual molecules taking into consideration. Okay, in microscopic approaches in thermodynamics, the behavior of individual molecules taking into consideration. Now this approach is also known as statistical approach of thermodynamics. And it may be used where the density is low, that means in higher altitude. It may be used where the density is low. So this approach is also known as statistical approach in thermodynamics, and it may be used where the density is low, that means in higher altitude. Okay, in the next video we'll discuss about the thermodynamics properties. Thank you.